Ms.Mariam. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Rafique. Today we're gonna start new chapter number 4, and the name of the chapter is Mass, Weight, and Density. Before getting into the core concepts of this chapter, I would like to share some learning outcomes so that by the end of this lecture, you will be able to state that mass is a measure of the amount of substance in a body. Mass of a body resists change from its state of rest or motion. And recall and use the equation weight is equal to mass times gravitational field strength. Now, who do you agree with? Is there a difference between mass and weight? No, mass and weight are the same thing. Weight is the force of gravity acting upon a person or object. Yes, there is difference, but I don't know why. So first we have to see that what is mass. We can say that the word mass to talk about how much matter there is in something. Matter is anything you can touch physically. On Earth, we weigh things to figure out how much mass is there. The more matter there is, the more something will weigh. Often, the amount of mass something has is related to its size, but not always. A balloon blown up bigger than your head will still have less matter inside it than your head, for most people anyhow, and therefore less mass. So mass depends on the number and kind of atoms, and the mass of an object is the mass of an object regardless of whether or where the object is. The unit of mass is kg. Now, what is weight? Weight is a measure of gravitational attraction of an object, and it is represented by g. Weight depends on where the object is. Your weight on Earth is not the same as your weight on the moon. And we represent weight is equal to mass into g. G is the force of gravity, and the unit of weight is newtons, and that can be represented by kg meter per second square. Now the difference between mass and weight is that weight is determined by how much something is pulled by gravity. So if we are coming or comparing with two different things to each other on Earth, they are pulled the same by gravity, and so the one with more mass weighs more. But in space, where the pull of gravity is very small, something can have almost no weight. So it still has matter in it, though, so it still has mass. So weight is a sensation of force we get as we press against other objects. You press against a scale to measure your weight. What pulls you against the scale? Gravity. Gravity keeps trying to accelerate us toward the Earth, and we get pressed against things. This gives us the feeling of weight. Our perception of weight can be altered by our environment. And that's right, that our perception of weight may be different in different circumstances. What about if you are on the moon? The moon has less mass, therefore less gravity associated with it. there is less attraction between your body and the moon. The moon pulls on your body less than the earth. So, you would press down on a scale with less force, and your weight on the moon would be about 1/6 of your earthly weight. What about weightlessness? Astronauts in space feel weightless because they aren't forced against the floor, but they still have mass. The weight of the astronaut on the Earth. The weight of the astronaut on the Earth is 12,000 newtons, while on the moon is 200 newtons. And the mass of the astronaut in both moon and Earth is same, 120 kgs. So we feel weight as a force, and you typically measure your weight in pounds. In the metric system, SI, weight is measured in newtons and is represented by capital N, and 4.4 Newton is equal to 1 pound. Since weight is a product of mass and gravity, the equation for calculating weight is W is equal to mg. Here W represents the weight in newtons, m represents the mass in kg, and what is g? G is the acceleration of gravity, symbolized by small g, and is equal to 9.8 meter per second square. At or near the Earth's surface, gravity tries to accelerate objects 9.8 meter per second faster each second. So weight can be represented in newtons, mass will represent in kgs, and acceleration of gravity represents by 9.8 meter per second square. It's the equation of force, and weight is a force. So when we talk about the force of gravity, we are really talking about the force of weight. So gravity is an acceleration. Now, important example problem, that Mr. O has a mass of 88.64 kgs. What is Mr. O's weight on Earth? So we will utilize the equation W is equal to mg. We are having the value of mass of Mr. O, that is 88.64 kgs. And we know the value of g is 9.8 meter per second square. By putting both the values in the equation and after multiplying, we get the weight of Mr. O, and that would be 868.7 newtons. Example problem 2. My first car was a 1964 1000cc truck, and if had a mass of 1814 kg on Earth, what would be the mass on the moon if g is equal to 1.2 meter per second square? Now the value of g is confusing here, but we know the answer, that the mass will be the same regardless of g on the moon. Then what will the truck's weight on the moon be? Yes, we can calculate that by using this equation again. W is equal to mg, and 1814 kg is the mass of the truck, and 1.2 meter per per second square is the value of g on moon. So after multiplying, we get the answer, that is 2177 newtons. 2177 newtons weight of the truck will be on moon. So we can summarize that mass is the amount of substance in the body, while the weight is the force of gravity acting on the body. Mass is constant in any location, while weight depends on the acceleration due to gravity at the location. Mass is a scalar quantity, while weight is a vector quantity. Mass can be measured in kilograms, while the weight will measured in newtons. So mass measured using a beam balance or electronic balance, while weight measured using a spring balance. Now the question here is that why mass is important. Mass is important because of two major factors affecting how things move in space: inertia and gravity. The more mass something has, the more of both it experiences. That is why heavy things, you can say things with a lot of mass, are hard to move. When an object is sitting still, it resists moving, and the more mass it has, the more it resists. So the amount of thrust needed to move something and how fast it ends up moving are both directly tied to its mass. On the other hand, once something massive starts moving, it is very hard to stop. And this is also due to the relationship between mass and inertia. And gravity is also proportional to how much mass each thing has. So the bigger an object is, the larger the gravitational pull it exerts. So thank you so much and good luck.